Hi guys, feel like I haven't talked to you in forever. All right, so today we're going to start something new. This will be the last thing we study. It's arithmetic and geometric sequences. Sequences and then another thing called series kind of are important in calculus, so this being pre-calculus, it kind of obviously fits. So sequences are just number patterns, and there can be all kinds of number patterns, but two of the most studied ones are arithmetic and geometric. So I'm going to sort of define those and talk about a lot of the details, a lot of the notation, and then obviously go through some of what you're going to be expected to do. So A1, as you can see here, A2, A3, A4, dot, 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 AN. Those are that is a symbolic way to represent a number pattern. So just take something really basic like 2, 4, 6, 8, dot, dot, dot. AN represents any generic term further down the sequence. So I could say, what's the 15th term of the sequence? That would be A15. Or what's the 1000th term in the sequence? That'd be A1000. So the dot, dot, dot means it could go on indefinitely. Number patterns can stop or they can go to infinity. It doesn't really matter. So an arithmetic sequence, arithmetic sequences have what we call a common difference. And if you watched the video yesterday like I asked you to, you will have already seen this. So a common difference is indicated with the variable d for difference, and you find the common difference by subtracting A1 from A2. Now that's at the most basic level. You should be able to subtract any two terms and get the same number. So for example, this would equal the same thing if I did A4, let's make that look like a letter A, A4 minus A3, or if I did A21 minus A20. So subtract any two adjacent terms in the sequence, you should get the same number, and that is called the common difference. If you don't get the same number, then it's not an arithmetic sequence. An arithmetic sequence has to be the same. So my little generic example up here, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. That would be an arithmetic sequence, and the common difference is 2. Okay, so let's say I wanted to find, the 15th term of the sequence. Well, there's a formula for that. To find the nth term, the 15th term, or the 20th term, or whatever, you use this formula right here. So it starts off with an, so that represents the term you're trying to find. You simply take the first term, whatever it is, add it to n minus 1 times the common difference. So if you want to find, let's say, like I said, the 15th term of a number pattern, an arithmetic sequence, let's say you discover, well, in this example up here, the common difference is 2, so d is going to be a 2. If you want to find the 15th term, you're actually going to multiply that by 14, n minus 1. And then add that to the first term in the sequence. In this case up here is a 2. And then that formula just cranks out the 15th term. Not going to do it. There's plenty of homework examples down below. Now a geometric sequence is a different type of number pattern. It might be something more like 2, 4, 8, 16, 32, dot, dot, dot. And then again, it could go dot, dot, dot to wherever, 50 terms, 100 terms, infinitely many terms. Geometric sequences have what we call a common ratio. Now, common ratio, ratio means basically fraction. So if you divide any two terms, you will get the same number in a geometric sequence. So like in this example, 4 divided by 2 is 2, but also 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2. So the fact that we get the same number each time by dividing means that that is a geometric sequence. Obviously it's not arithmetic, because if you subtract these two you get 2, if you subtract those two you get 4, so it's not an arithmetic sequence, but it is geometric. So in this sequence, let's say I asked you to find the 7th term, and you didn't feel like extending this out 7 places. You could find the 7th term by taking A1 here. So let's say I had to find A7. Take A1, which is 2. The first term is always A1. times the common ratio, which in this example we just said is 2, to the n minus 1 power. If we want to find the 7th term, we're going to raise that to the 6th power. N minus 1, 7 minus 1 is 6. And then just work that out on a calculator or whatever, and you would get your answer. So that's what we're going to be looking at here. Now, in the first first 6 problems, we are studying arithmetic sequences, and the first thing is to determine if it's arithmetic or not. So remember, you have to be able to get the same answer anytime you subtract 2 pairs of numbers. And you always have to take an element of the sequence minus the number in front of it. Now, number 2, my first example that I do, if you subtract these 2 numbers, you get 0. These 2, you get 0. These 2, you get 0. And you'd say, oh, you get the same number every time. That must be an arithmetic sequence. Actually, it's not considered arithmetic. It's considered trivial. If you just repeat the same number over and over and over, there's nothing interesting about it. So if it is not a common sequence, and this is kind of a weird example, you just write not and move on. You don't have to do anything else. But let's look at number 14. If I do 21 minus 13, what's 21 minus 13? 8. 29 minus 21 is 8. 37 minus 29 is 8. Same number every time. This is arithmetic, so I'm just going to do a little yes. Now, find A20. So, what was the formula up here? Right there. Here, I'm going to do something special. I'm going to duplicate that, see if I can drag it all the way down. And I bet I'm going to wish I had brought up a calculator. But anyway, so here is the formula we're going to use. And so to find A40, the 40th term, obviously you do not want to continue this out 40 times or 36 more times or whatever. That'd be crazy. So use the formula A1, which is the first term, that'd be 13, plus n minus 1, well, n is 40, so 40 minus 1 is 39, times d, the common difference. Remember what we got when we subtracted each time? We got 8. So 13 plus 39 times 8. Okay, I got to find Desmos, and then I need to pull up, let's see. I can make this work. My iPad isn't wanting to cooperate right now. There we go. And I just type this in. So 13 plus 39 times 8. So if we were to extend this pattern out to the 40th element, we should get 325. So is this an arithmetic sequence? Yes, we got 8 each time. Let me make sure I'm not skipping any of the directions. Find the common difference. The common difference we found, it was 8. And then the term named in the problem. That'd be A40. That was the term named in the problem. So the 40th term is right there. Let me go ahead and check this down below. Wow. There we go. Make you dizzy. So, all right, they didn't write yes, but there's our common difference, and there's our 40th term. Okay, number 6. So, first of all, is this arithmetic? So we need to subtract these. Now, there is a temptation, and this happens in the earlier grades, to be honest, but still, anyone could fall for it, to look at this and go, oh, 15 minus 11 is 4. 11 minus 7 is 4. 7 minus 3 is 4. But remember, you're supposed to do 11 minus 15, and then 7 minus 11, and 3 minus 7. The common difference is actually negative 4, not 4. And that is critical. I mean, that makes a difference. So, is this arithmetic? Yes, it is, because you get the same common difference every time, and that common difference is 4. Now, we're supposed to find A32. Let me see if that, yep, A32, the 32nd term. And again, we don't want to keep subtracting 4 over and over and over until we get to the 32nd one. So we're going to use the formula. So A1, which is 15, plus n minus 1. So the 32nd term is going to be 32 minus 1, that's 31, times d, the common difference, which is negative 4. So let me type that in. 15 plus 31 times negative 4. And negative 109 should be the 32nd number in that pattern. Let me scroll down to number 6 and see. And we are correct. Negative 4, negative 109. So there's the first 6 problems. If it's not arithmetic, if you don't get the same common difference, then you just write no or not. Not doesn't sound like good grammar. You just write no and then move on. But if it is, you circle the common difference. That's one of your answers. And then you run through this formula and circle that, and that's your second answer. Now in the next set of problems, determine if the sequence is geometric. If it is, state the common ratio and the 8th term. So we're going to do the 8th term every time here. With geometric ratios, if you try to find the 32nd term or the 40th term, you're going to get into really huge numbers. So it's not unusual for a worksheet to just limit the question to a fairly small number. Kind of defeats the purpose because, yes, you could just continue to get to the 8th, but we do want you to learn how to manipulate the formula. So here we go. All right. So we divide. What is 16 divided by negative 16 divided by negative 4? Let me go down below here. Negative 16 divided by negative 4 equals 4. What about negative 64 divided by negative 16? 64 divided by 16 is also 4. The negatives cancel out. What about 256? 256 divided by 64. Again, the negatives cancel anyway. So this one also equals, what is that, a sad face? Also equals 4. So is this geometric? Yes, it is. We got the same ratio each time. So I'm going to circle 4. That's the common ratio. Now we have to find the 8th term. So let me write the formula, see if I can do it from memory. A sub n equals a1 times r to the n minus 1 power. All right, I got to check myself. Yep, okay. I guess I don't really need those parentheses up there, but that is the formula. So we're doing a sub 8. We're finding the 8th term. So a1 is right here, a1, so that's negative 4, times r, which is 4, right? R is right here, to the n minus 1 power, so this is going to be to the 7th power. So negative 4 times 4 raised to the 7th power, negative 65,536. And again, when you start raising numbers to powers, you get really, really big numbers, or if they're negative, really small numbers. But they get very unwieldy. So yeah, find the 8th term, find the 9th term, find the 5th term. That's the kind of thing you generally do here. Oh, I suppose I should check myself, because it'd be embarrassing if I'm wrong and I'm going on and on. There it is. Okay, number 10. So the common ratio, negative 2 divided by 1 equals negative 2. 4 divided by negative 2 equals negative 2. Negative 8 divided by 4 also equals negative 2. So negative 2 is the common ratio. It's definitely geometric. Find the 8th term. A sub n equals a1, the first term, times r, which is negative 2, to the n minus 1 power. Again, that's going to be to the 7th power. For finding the 8th term, I guess I wrote that wrong. That should be sub 8. The 8th term, 8 minus 1 is 7. So I'll type it all in. I guess I don't need to do, 1 times negative 2. I could probably figure that out without a calculator. Raised to the 7th power, and this should work out to equal negative 128. Let's check number 10. Negative 2 and negative 128. All right, one more and we'll lock this up. So, is this geometric? 8 divided by 4, 2. 16 divided by 8, 2. 32 divided by 16, 2. It is geometric. The common ratio is 2. Find a sub 8, the 8th term. We need to do a1, the first term, multiplied by 2, the common ratio, to the 7th power. Remember, 7 comes from this number minus 1. And I'll use a calculator for that. 4 times 2 raised to the 7th power, 512. So for number 12, we should have 2 and 512. So when it comes down to it, you're learning some formula manipulation. The variables or the notation, I guess, not symbols, the notation that's used, we use a lot of subscripts. Use the same variable over and over, a, but A1, A2, A3. That depends on, what number in the sequence. A sub n, you have to get used to. Sometimes you'll hear the expression, find the nth term. So that could be like the 50th term, the 42nd term, the 13th term. So find the nth term refers to a sub n. So what's the takeaway? Know this formula, understand how to find the common difference and the common ratio. Remember, common difference goes with arithmetic, common ratio goes with geometric, and after that it should be fairly straightforward. As usual, if you have any questions, contact me through the normal means. Otherwise, good luck with this. Check your work, turn it in, and have a great day. Bye-bye.